Okay, next topic is couple. So, what is made by couple? For example, you will have equal and opposite forces because of which the net force is 0. So, we are having equal and opposite forces. But these two forces acting along the different line. So, as a result, there is a rotation which is happening. So, a pair of equal and opposite forces with different lines of action. So, as a result, the rotation without translation. That is, if one object is having equal and opposite forces and the net force is 0, so what is the result? It is in rotation without translation. So, now let us see one example. Let us look at these examples. You having this rod, you apply equal and opposite forces to the rod at the both side of the rod. Now try this. What will happen? This force will take it up and this force will take it down. As a result, the rod starts to moving in an anti-clockwise direction. So the rotation will happen at anti-clockwise in an anti-clockwise direction, right? So that is what happens. So the rod will start to move in this direction. So these kind of force is known as what? Couple. Okay, next topic is principle of moments. So now when I say a principle of moments, what do I refer? That means when I talk about moment, so moment is nothing but torque. So now let us see the example of seesaw, which you often seeing in children park. So it is a rod-like structure where you have two seaters on the two ends at some point, and there is a fixed point between the two ends. Okay. So now this point is known as what? Fulcrum. So fulcrum is the point around which or about which the two ends move with respect to each other. Okay. Now let us assume that is suppose a force F1 acts at one end and force 2 that is force F2 acts at other end. So that is one child gives one force and here another child gives one force here. Okay. So because of this fulcrum there would be a reaction force in the opposite direction. Okay. So that is given as about R. So the distance of this is D1 and the distance of the other end is what? D2. Okay, so the distance of this other end is what? D2. Now alterate for this lever to be in equilibrium. So for mechanical equilibrium, we have to ensure that there is a translational equilibrium. Okay, as well as rotational equilibrium. So we need both translational equilibrium and rotational equilibrium. So when I talk about the translational equilibrium, that is I mean that the net force is equal to 0. So what is the net force here? R. So R is the force which is acting upward and R minus F1 plus F2 which is acting downward. Okay, so this is a net force acting in the system. So this will be equal to what? 0. So this implies that is R minus F1 minus F2 is equal to 0. Also it is in rotational equilibrium. That means the net torque equal to 0. So now what is torque? That is torque is given by R cross F, where R is the position from the origin. So here fulcrum is considered as origin. The torque on one end is D1 F1 and the torque on the other side is D2 F2. But in this case the direction of torque is R cross F. So if you curl your finger in this fraction, you get the direction of the torque as your thumb pointing towards yourself. Whereas in the other case, when you pointing D2 cross F2, you can see your thumb finger pointing in the downward direction. So that is what? Opposite direction. So here we will have D1 F1 minus D2 F2 have the negative sign because in this case the torque is in the opposite direction. So this will be equal to 0. So now this equation is very important equation. So in this equation we called F1 as load. Okay, F1 as load and F2 is known as what? Effort. So this is load and this is effort. Okay. So therefore the distance from the load to fulcrum is load arm and the distance from the fulcrum to effort is known as effort arm. So D1 is equal to load arm and D2 is what? Effort arm. Right. So therefore we can write this equation. Okay. So we can write this equation as D1 F1 is equal to D2 F2, or this can be written as, that is D1 F1 is written as load arm into load, and d2F2 is written as effort arm into effort. So this defines the principle of moments for a lever. Okay, to ensure rotational equilibrium in case of a lever, we should ensure that the load arm is multiplied by load should be equal to the effort arm multiplied by the effort. So we often define in another term known as mechanical advantage. Okay, so which is abbreviated as a MA. So this is the mechanical advantage. So which is a ratio of F1 by F2, that is load to effort, which is equal to D2 by D1. So this is how we define mechanical advantage of lever. So the mechanical advantage of the lever is a ratio of the load to the effort. Okay, so now this mechanical advantage help us because in the mechanical advantage the value of that is the value is very high, that is F1 is greater than F2, that is a large amount of load is required in all to get a small amount of effort. Okay, whereas it that is if the mechanical advantage of a lever is very small, that means F1 minus F2 is very small. So F1 is very less than F2. Okay, small amount of load can give you huge amount of effort. So now let us see the two cases. First one is mechanical advantages is greater than 1. Okay, so what will happen? And then mechanical advantages is less than 1. So now let us see the first case, mechanical advantage is greater than 1. So it is very greater than 1. So F1 by F2 is greater than 1, that is implies F1 is greater than F2. If it is less than 1, so F1 by F2 is less than 1, which is equal to F1 less than F2. So this is the principal moments of a lever. So next is center of gravity. Since we are talking about equilibrium, so it is good to talk about center of gravity. Okay, so it is basically that is center of gravity as that point where the total gravitational torque on the body is 0. So that is, let us say any object, for example, any object which you would try to balance with your finger. What happens? There is a gravitational pull always being exerted on that object, because of which the object tend to fall on the ground. Okay, so when the net gravitation torque on the body is 0, that is, when you place your finger exactly at that point where the total gravitational torque is 0, then we would say that the object is in equilibrium. So the center of gravity is that point where the total gravitational torque on the body is 0. So at the center of gravity there is no rotation involved on the body. So this is, you can take an example that I mentioned now. If you do not place your finger at the exact point, if you move your finger that is even little, what happens? The disc starts toggling. It is no more balance, it starts toggling and tends to fall down. Sometimes it's toggle on the right hand side and sometimes it's toggle on the left hand side and so on. So center of gravity means a point where the total gravitational torque on the body is 0. Okay, now let us say bending of cyclist in curves. Okay, which means how the cyclist bending in the curve without falling down. So see this diagram, this is the path that the cyclist is coming, and see this road, the road has bent. So he is bending. Suppose he is not bending in the curve road, he is coming straight. Suppose he is coming straight and he is not bending at the bend. So what will happen? He starts to fall down. So here we consider rotational frame. Okay, so every object in the rotational frame contains a pseudo force, that is centrifugal force, mv square by r. So when the cyclist will not bend in the bending road, then he will slide on the road. Okay, so if he should not slide on the bending road, what will happen? If he not slide on the which means He should not slide on the bending road means what will happen? Then he should not bend along the rotational force. Okay, so that is he is unstable at equilibrium. So the centrifugal force, that is mv square by r, is the opposite of gravity, mg. Okay, so both the forces are acting opposite direction. Okay, so if the centrifugal force and gravitational force are in equal and opposite directions, okay, both the force are in equal and in opposite equal and opposite direction means then the cyclist will be stable at the rotational path. So now what we are going to find is, we know that the rotational system is unstable when the total torque must be equal to 0. So the total torque, that is net, that is total torque, is equal to 0. Let us take this diagram as mathematically. Okay, now we are going to take the diagram as mathematically. So the cycle is acting as a radial vector. So this is the radial vector. So the centrifugal force, that is mv square by r, is moving the radial vector by in this direction. Okay, and mg is taking the radial vector as downward direction, but both the forces are different. Okay, so we know tau is equal to, okay, tau is equal to f vector cross r vector. So when we find magnitude for this, we use, if you want to find the magnitude, so we use f is perpendicular to the r. So the torque produced by mv square by r and torque produced by mg are in equal and opposite. So the cyclist can easily bend in the. Okay, now we are taking mv square by r. So if you are taking the mv square by r, that is centrifugal force. The centrifugal force is acting in this side. So what is the perpendicular to mv square by r? So that is what? BC. So BC is the perpendicular to mv square by r. Okay, so that is mv square by r into BC. And if you are taking the gravity, that is gravitational force, mg, and what is the perpendicular to mg? So the perpendicular of mg is what? AB. So mg into AB. Okay. So if you see this diagram, this is angle theta and this is also another angle theta. So the theta is opposite to AB. So is at opposite of theta. So we can write AC sine theta. And here BC theta is an adjacent side. So we can write AC cos theta. Okay. So now we are going to apply this. Okay, now if we are going apply, now we are applying this. So mv squared by r. Okay, mv squared by r. What is BC here? So BC is what? AC cos theta. So we are putting AC cos theta is equal to mg. And what is AB here? AB is AC sin theta. So AC sin theta. Okay. So now we are cancelling, m and m will get cancelled, and here AC and here AC will get cancelled, and remaining v squared by r cos theta is equal to g sin theta. If you are bringing sin theta here, then sin theta by cos theta is equal to what remaining? V square by r into g, that is v square r g. Okay. So sin theta by cos theta is equal to nothing but tan theta. So tan theta is equal to v square by rg. So if we are moving tan that side, so theta is equal to tan inverse of v square by rg. So we can find how the cyclist is bending in the curve.